we turn to him, I want to tell the story about what we were going to do at the start when we were hastily trying to put together the program for today's meeting. Um, and I had asked Chat GPT if it could do a presentation. It explained to me that it couldn't join a Zoom meeting, but could send me an audio presentation. So but along with that, it's also asked me if I wanted to include slides. So I said, sure. And then at some point, that was earlier in the week, I asked ChatGPT how would the slides work with the audio presentation. Me trying to avoid a circumstance where I was manipulating a PowerPoint or Keynote for a ChatGPT talk. So the bot suggested that what it could do would be to send me a video with the talk synced to the presentation. And early in the week, it said it could send that to me by Friday. So one thing is I had never asked a bot to do something as, like this, and never before, ever had ChatGPT said to me, I'll get back to you on Friday. Well, Friday came and went, and there was no video. Early this morning, I said to ChatGPT, what happened to the video? Oh, we're working on it. We're working on it. And it so resembled a recalcitrant student. Well, at this point in the meeting, do you think I've gotten the video yet?
A bad intern, I think, Jonathan.
um, so rather than torture myself anymore, maybe what we will do instead is actually turn to the live person who is an extraordinary professor at George Mason, the university where we long held our meetings and where we have the Great Pi Scholarship. And Professor Nowzari has a really interesting field where he actually studies the how to make devices more effective, use less energy and less consumption, so tighter coding. And then if you think about it, this has application to a huge number of different fields. If that's enough of an introduction, Cameron, may I turn the floor over to you?
That's fine with me. Hello, everyone. My name is Cameron Nowzari. I'm an associate professor in the electrical and computer engineering department at George Mason. I must apologize in advance. I have pretty much nothing prepared. I've stitched together a few slides from old lectures and talks I've given to try to just maybe, stimulate some discussion about AI in general, what AI even is, what the futures of it might be, or, what we really should be thinking about or not be thinking about for trying to predict the futures of AI. So I kind of liked what this small exercise that was already done because for anyone who doesn't really know how to use ChatGPT, for people who know that it exists but haven't really played with it, I generally recommend them to actually treat it like, some 18-year-old high school intern that you don't really trust and just, give them some tasks and sometimes they may surprise you. So in this case, it didn't kind of work out, but I think I expected that. So with that, I did want to see, am I able to like do polls? I
Yes,
was curious if I'm able to.
you should
Yes.
be able to, but I think what I have to do is make you a co-host. So let me quickly do that.
And let's see if we can. Slides.
Okay, so now that you're a co-host, you should see host tools
All right, let's see here. Let me.
and under more polls. Let me know if you don't see that.
Okay, yeah, let's see how easy or hard this is. I might have to just type in the chat real quick, but yeah, no, I'm not sure. I don't think it looks like I can launch some poll that is already there, but I'm not sure if I'm able to customize any questions live.
Try it now.
Did something happen? There's
No,
only this. All
if
right.
we end, let me end this one. And now,
Yeah, I mean, if you're able, I have actually, I guess here, I have the question here. If you're able to just somehow generate a poll with just A, B, C, D, E as 5 responses, that would be fantastic. But if not, that's fine. I'm just trying to get an idea of the general AI literacy in the crowd because, you know, depending on how often people use AI, they will have very different thoughts and opinions and answers to the types of questions I will pose today.
yeah, so what do you want the questions to be?
Are you seeing my screen right now? Do you see this warm-up graded clicker question or no?
Yes.
Okay, so yeah, so this, so you know, I mean, I'll just start with this. Maybe everyone here already knows what Skynet is, the AI in Terminator that kind of took over. But the technological singularity, or simply the singularity, is a hypothetical future point in time at which technological growth becomes uncontrollable and irreversible, resulting in potentially unforeseeable consequences for human civilization. So, you know, a common theme in a lot of movies. But the general question just is, do you believe something like this is possible someday in the future? You know, even if that's 5 years, 500 years, or 5,000 years. You know, just think about your answer. If you, I don't know if you want to maybe just type it out in the chat. Generally, this is a pretty split answer. So everyone from definitely yes down to definitely no. So it looks like in this group we have definitely yeses. So maybe depending on what the consensus looks like, I'll try to sway your opinion in the other direction and maybe put your mind at ease. And I'll just say, I think my opinion on this sways quite often. So I'm not here to give an answer on this, but to maybe give you a few more things to think about, and you know, hopefully put your mind at ease too.
Okay, so I've launched the poll that
You did.
you asked.
Wait, sorry, I might have just actually ended it. Let me try that again. There. Oh, great. Oh, perfect. That worked. Okay, so maybe we'll wait 20 more seconds. It looks like already 12 people have answered, so. Okay, so interesting. Actually, nobody in this group is saying definitely no. Are we able to share the results? Can everybody see the results, or is that just me?
Yes, once you end the poll, you can share it.
Well, I didn't start the poll. I thought you did that. So if you want to just go ahead and end it and share it, that would be great. Perfect. Okay, so 2 out of 17 said definitely yes, 6 said likely, 5 said maybe, 4 said unlikely, and nobody said definitely no. So that's actually quite interesting. And so maybe let's now tell a few stories about this and maybe get into a few more detailed questions about why this might be. So I can stop sharing this for now. So okay, I'll skip this one. So actually just 2 more questions to get an idea of the audience here. So are you able to generate one more similar to this? How many different AI programs have you personally interacted with? So I've listed just a few of these. There are so many. ChatGPT, Midjourney, Bard, Chat Sonic, Claude, Lambda, Jesper Chat, Socratic, Bing, oops, OpenAI Playground. I guess, yeah, I don't think I could do the poll. So if you're able to do this again, that would be amazing. But I don't need to wait too long on this one. There's a few nevers. This is interesting. So I should also share. So as you're seeing, this is part of a lecture I do in my ECE 101 class, which is predominantly 18-year-old students fresh out of high school. And I've been doing this, will be my third year doing this coming fall. And I do believe we're kind of at this inflection point today, where 3 years ago, about 10% of the class had regularly used programs like this. And I believe within the next 2 years, it's going to be 90%. So great. Looks like thank you so much for doing these polls. I think this is actually quite useful for me because this demographic is a bit more, it's quite different than the 18-year-olds I'm used to. That's a good thing, I think.
In what respect, Cameron?
Well, a lot less interaction with the AI. So here we can share this result, right? So it looks like 35% of you have never interacted with anything, including ChatGPT. So that is actually quite surprising. 55% of you have interacted with one or two of these. So I assume ChatGPT and maybe one other. But yeah, nobody here has actually played with 6 or more of these, right? So I can tell you these 18-year-old students, this is just skewing downward. I don't think there's anybody who's coming into my incoming freshman introduction to electrical engineering class who's never touched these. And then I think about a third of the class has used 10 or more of these different programs. So that's already, something to think about. I've listed about 20 different programs here, and they all do different things. ChatGPT is kind of the biggest general purpose one, but then a lot of different ones either use different methods or specialize and focus on very specific things. So a lot of these students will use 7 or 8 different AI agents and kind of weave their skills together. So it's quite interesting. Final question. Oh, sorry, this one. And please, I would love this to be a discussion. So if you want to just chime in and say anything, ask a question, please do.
Yeah, Gabe, go ahead.
My question is, with people using that number of different AI systems, are they paying for them or are they using the free versions of all of these? Because obviously paid versus free changes your perspective.
Yeah, no. I mean, that's a great question. So I'd have to definitely poll on that to get accurate numbers. But I mean, that would be a wide spectrum. So I imagine some students would pay for 1 or 2, use 7 or 8 other free things. I mean, I have a PhD student who pays for like the pro version of ChatGPT, which is $200 a month. And, that kind of does heavy lifting. But then they even alternate subscription. These are all subscription based. So maybe they'll use ChatGPT's $200 version for 2 months, stop paying for that, try something else. I mean, the thing is, these are all new. They're all changing so fast. So it's quite natural that the students are moving around a bit too, as even the performance of these programs change, because there's a lot of competition.
Yeah, I've used Chat GPT and Copilot because that's handy. Microsoft inflicted the icon on the taskbar, so that's just easy to get to. And I've played with Perplexity a little bit. Perplexity is very well regarded in a journalists community that I'm in.
I really like Perplexity. Perplexity, I think of as kind of a more intelligent Google in some sense. But it's really hard to even just be told by someone what they do or what they're good for. One, because people use them differently and they're always changing. So honestly, in doing these exercises, I have to admit, I'm probably only at a number of 5 to 10. I've not tried more than 10 different programs. And, again, I'm someone who probably needs to interact with these things more, because that's the only way you can truly understand what they do, how well they do it or don't do it, as you kind of learned very recently, Jonathan.
Another question maybe to ask is what people think and how much people are using AI when it's inflicted by the technology companies. For example, the Washington Post stuffing its comments technology with a stupid and lame AI summary at the very beginning, and Google inflicting AI cruft at the beginning of search results. And apparently, some of those things just can't be turned off.
Yeah, no, that's a great point. And actually, I think maybe today or this week, until this week or so, YouTube allowed AI generated content to be monetized. So there's been so much flood of AI garbage that's essentially recreating old videos, and then the authors get paid for it. But yeah, I mean that's a great question. And even there's one in the chat about is Grammarly an AI? It's hard to even answer a question of is something AI, yes or no. It's more like AI is slowly creeping into all these different programs. So yeah, one more poll in case you missed it. Most of you have answered, but in case you haven't, this question is slightly different. How often do you intentionally interact with such systems? Any type of AI. So never, or once a month or less, or a few times. Yeah. And so yeah, again, I think here we're definitely seeing a split. I think the younger people in general, they're just much faster adopters of this technology. They're happy to try everything. And I guess, yeah, we have most people responded, so I can share these results. Only one person here said they use these things every single day. So again, the 18-year-old camp, this is probably at least over 50% now.
So Cameron, one of the problems is that since I'm an admin, I can't respond to the poll.
Okay. Well, that's fine. So slightly skewed, but regardless, I think the results are kind of telling that, just if you aren't interacting much or intentionally, there's a lot that's happening. And I mean, so yeah, it might be worth just even sharing my own experiences, because my own usage of it is ebbing and flowing all the time. When it first came out, I used it every single day for a lot of different things. And then slowly over time, they started changing how it works, right? So they start trying to filter its responses. People learn how to jailbreak it. So then they have to fight against that. So this is good and bad. One of the bad things I found was that it became harder to use ChatGPT as a tool, because in some sense, they're trying to make it less robotic. But, if I'm trying to use it to process some data, I want it to do it the same way every single time. But with ChatGPT, eventually it got frustrating where I would ask it to do something like, oh, can you generate a QR code for this? And maybe 3 out of 5 times it'll do it perfectly. One time it'll tell me it can't do it. And one time it'll tell me, oh, that's unethical. We could never do that. And I have to argue with it and trick it into doing it. So, when it gets to a point like that, it stops kind of becoming useful. But again, these things are constantly evolving, and then there's other programs being created all the time. So how you use it, how different people use it is very different and changing all the time. And understanding these kind of good practices is interesting, if nothing else. Okay, I guess these. Sorry, my thing froze. Okay. Okay, so so now let me just tell a few stories kind of about this kind of the debate. So again, in my class, generally the opinion is pretty split, 50-50, and then we tell a few stories that start to skew the opinion one way or the other. So some of the most common arguments that we hear for the people who say definitely yes, AI is going to take over, or these. And if anyone has any additional arguments, please share them. This should be an open debate. But the two main ones are the speed of AI is evolving so fast, right? Which is definitely undeniable. It is only a matter of time until its capability surpasses ours in the areas humans are still better at it today. So we'll look a little bit about what humans are still better than AI at and maybe why. The second one is AI constantly takes actions that were unintended or even unheard of to their own designers. So, kind of when you take these two things together, people think, of course, this is going to eventually happen. Look how much computing power it has and how fast it's learning. And it does unpredictable things all the time. Eventually, it's going to be unstoppable, right? This is the main argument for the yes, it's going to take over side. On the no side, so the most common one is, AI is, artificial, right? So it doesn't have emotions, doesn't have feelings or thoughts like humans do. So they just follow instructions set by people in the end. So even advanced AIs like Chat GPT are just tools made by humans. They don't have minds, right? They can't think on their own, whatever that may mean. AI is just lines of code, right? So a single typo or error can ruin it. It will never be perfect. Yeah, Jonathan, please.
Actually, it's interesting. Gabe and I were talking about this, and the question that comes out of it was, is it quintessentially human to learn by actual experience using our senses? And to what extent can just data fed to an AI bot substitute for that?
Yeah, so that's a bit of a loaded question, and maybe I'll even narrow that down to say there's a very troubling and a single loaded word in that entire question, which is learning. Uh, this is what Rodney Brooks calls a suitcase word. Essentially, when somebody says this robot learns, and we're using that the same way as maybe a child learns a new language or learns to write or learns to speak. But you can we teach machines to do things. Sometimes when we say learn, we just think of pattern matching. So when we say, actually, sorry, how did you phrase your question about the data stream, Jonathan?
Sorry.
Yeah, no. So I said, how did you? I forgot how you phrased your question about the.
How close to exposing AI bots to data can that be a substitute for the way humans and animals use their physical senses?
I see. Yeah, no. So data is always
There's a
being
follow-up
fed.
to that. So
Data is always being fed to the machines, just as we are being fed data or information through our senses, right? Even like touch information is just information coming in some sense. But then, yeah, I'll just go to this final point, which is that what the human versus the machine does with the data is the difference, right? So an AI always needs the human to tell them what a good or bad thing was, what a correct or wrong operation was. Humans are biological animals, right? Don't have this. So ChatGPT's web scraping too is also dependent on humans. In the end, it's always dependent on humans. So even if it has access to a whole bunch of data, it still has no notion of something to do with that data without being told what a good or bad thing is. And yeah, Gabriel, you have your hand raised.
Yeah, that sort of gets to the point that I was going to make, which is what passes for AI now is just pattern matching. There's no awareness of what the data means. And people have called it a fancy autocomplete or a stochastic parrot. It's basically just guessing what the next word should be. And that's very fast and very impressive most of the time and horrifying some of the time, but it's not intelligence. And so I didn't say never because never say never, because people have been saying never for hundreds of years and then things turn out to happen. But my belief is that some new implementation, some new technology, some new computing facility will be required to get to singularity when the artificial really is intelligent, and I'm not convinced it's ever going to happen. But still, I'll stick with never say never. But for now, all you're getting is pattern matching, and especially now as AI is ingesting output from AI, to some extent, there's a sort of spiral of doom where there's more garbage being ingested by AI, which then gets regurgitated.
Yeah, no, that's exactly right. So I mean, even it gets tricky with ChatGPT, and we kind of try to say it's doing more than pattern matching just because, I mean, a technology that's far enough advanced is indistinguishable from magic, right? So we can't really fully understand what it's doing. So we, use a word like, oh, it learned as kind of an explanation that we don't fully understand. So, I mean, a simpler example would be if I had some kind of thermostat that was programmed, if I asked it, is it hot or cold right now? And it responded, it's hot right now. And if that thermostat was programmed to simply report, say, hot if the thermostat is above, I don't know, 72 or something, right? And report cool if it's under that threshold, I think anyone would agree that this is not an intelligent machine. But then my question then, oftentimes this boils down to a semantics question. So where exactly then is that line where we would call that machine intelligent or autonomous or sentient or self-thinking, right? So if that machine then realized the person asking it looks like they're sweating and actually gives a response that says, the temperature is 80, and in general, I might say hot, but that doesn't always apply. You look like you're sweating, so I would say you are hot. But for some other animal, maybe it's cool. Would that qualify as intelligent? Like, where would that line be? And essentially, that's what this debate usually comes down to. What is autonomous? What does it mean for an agent, an artificial agent, to be truly autonomous? And so oftentimes I think that's where the debate ends up. And then it becomes a question of, where that line is. So I'll try to give some kind of answers, at least opinion about what, or at least clues about what I think about this. And then essentially, I do agree that with the current paradigm of large language models and the way OpenAI is just throwing more and more computing power at AI type of actions, I don't think it will ever get to a point where the singularity can happen. Quite frankly, because of this last fact here, that an AI system, LLMs today, they have no inherent compass that can be redefined without a human. So it's not really possible for a machine to one day change its own goals. So now we can get into the back and forth of this, because now people would argue with me. So for instance, I will skip some of these arguments because you guys are admittedly a lot faster than the 18-year-olds. So I wanted to just get to, I think this one. So I think the most compelling argument about, okay, you know what? Maybe the AI can't become sentient, but it could still unknowingly decide it doesn't need humans anymore. So this maybe has a bit more credence. And if you've heard of something called the paperclip maximizer theory, it's the same idea. So the idea of the paperclip maximizer theory is, what if you design a robot or autonomous agent whose goal is to just maximize paperclips production? The more paperclips it can produce, the better it's doing in its artificial programmed life. And so if that agent, this autonomous thing, gets so good at maximizing paperclips, it decides, oh, humans are a waste of resources because I can't produce paperclips because they're using resources to build other things where I want to build paperclips, right? So maybe the machine decides the humans are in the way of producing paperclips, right? So in some sense, would that qualify is another type of debate this might get into.
It seems to me that the paperclip maximizer is like the sorcerer's broomstick in Fantasia, where the magic broomstick is told to fetch as much water as possible, and it simply gets out of control.
Right. But so in the end, all AI is kind of built this way. In the end, when being saved on video, I'm a little hard pressed to say never, ever, but I really believe. Sorry, I guess I forgot where I was going there. But the point is, there always needs to be a defined objective function or metric, or even an explicit equation or number that the machine needs to be able to measure to know whether it's doing better or worse in some task. And in the end, that has to be programmed in by a human, right? So a machine to be able to compare action A versus action B, in the end, it has to be told which is better. So I'll skip these ones too. Yeah, and I don't think I want to show these videos. I'll just maybe leave this on the screen. For anyone interested, this is a great over 1 hour talk by Rodney Brooks, who's the inventor of the Roomba. And he talks a lot. He has something called the 7 Deadly Sins of Predicting AI. And I'll talk only about 2 of them briefly, but the video is great for anyone who's interested. One I already mentioned a little bit, which was the suitcase words. So essentially, the problem, even when talking with people predicting AI, is again this word just learning and intelligence, right? So when somebody claims that they have a learning agent and it's intelligent and it learns by itself, as an engineer, as a roboticist, I really can't take any meaning in this phrase like that, right? That only prompts a lot more questions to me of, well, okay, what does learning mean here, right? Because that word alone, without any context, doesn't mean much. And again, the problem is with a lot of laymen in this field really just trying to throw AI at all their solutions. They really don't understand what tools they have, or rather, what the tool they're trying to use is capable of and is not capable of. So I think I'll just kind of end there. If there's any other random thoughts about AI, I was just going to talk a little bit briefly about what my more traditional research is, and then kind of bring this back to what my final opinions about AI might be.
Are there any other questions for Cameron before he goes on? It looks like you're safe.
Great. So, I'll just say this is only one small theme of my research, but one of I guess, the longest running themes of my life is how does a single person control a swarm of robots? So how does one person control 100,000 robots, 1,000,000 robots? And I'm very interested in the theory behind this. So just a little bit about my background. In 2005, my undergraduate capstone project was on swarm robots. I had a $500 budget to buy some robots and try to get them to run around in circles. And so, now 20 some years later, I've gotten quite a lot of funding from both the Air Force and the Navy to do this type of research and develop these types of systems and actually bring them out into the real world to solve problems. So, a lot of people ask me, do I do AI? I used to answer no, because in some sense my research wasn't directly in the AI field, but I think as with anyone else, it's impossible to not touch AI these days. And in the end, I am just trying to design systems that are in some sense intelligent. But in the end, what I mean by that may be different from what somebody else means by an intelligent system. And for me, I just mean a tool that can be used under appropriate conditions. So I'm very interested in trying to deploy large swarms of robots that can actually be useful, where it's not intended that the robots do everything and know everything. So you'll see that I actually, with this whole philosophy that, artificial intelligence still requires humans, I try to design robots that always thinks about how humans are going to use them as part of the design. Alan, I see your hand raised. Did you have a question?
Yes. I was curious about your experience with the Chinese bot. Have you used the Chinese one?
Which do you have a specific robot in mind?
No. He's talking about the DeepSync app.
Oh. I mean, I haven't used that personally. My understanding is just a lightweight version of LLMs that exist. But I mean, yeah, that's just another example of another LLM. It's similar to Chat GPT. It does similar things, but it just uses an underlying different method.
You don't think it's any more powerful or any less powerful than Chat GPT?
Uh, that I don't. So I haven't personally used it, and so as I said, I really believe unless someone really truly interacts with it and tries to use something, it's really hard for them to say anything about it just based on what others are saying. But I think it's very similar to ChatGPT. I wouldn't have any reason to believe that it can't do as much. I also don't think it can do anything significantly better or faster. I do understand it's cheaper in some sense of resources,
So,
but
Okay,
again,
thank you.
these are types of things
Cameron,
that will
so
be developed.
Cameron, are you a Californian?
I am originally from California, yes. So I went to, as you can see here, UC Santa Barbara and UC San Diego for my bachelor's, master's, and doctoral degrees. And then I moved to the East Coast, University of Pennsylvania. I was there for 3 years, and I've now been at George Mason the last 9.
How did you get involved in epidemics?
Uh, that's actually a fun bit of story. I was actually looking when I went to Penn at computer virus spreading. And back then, I used to be a very theoretical researcher. So my PhD was a lot more theoretical and mathematical. So I was just interested in the network science, the math behind the spreading of computer viruses at the time. And then COVID happened. And the interesting thing was at the theoretical mathematical level of computer virus spreading on an internet network was not much different than a biological disease spreading on on a human network, social networks, even airplane networks, transportation networks. So that really was kind of a pivot because of the COVID pandemic. Overnight my research became highly relevant and hot. I got several grants through even the $2 trillion whatever act that was passed at the time, right? So they heavily invested a lot into COVID research. Uh, the nice thing about doing math and theory is that it was very easy to pivot my research on computer virus spreading to COVID. And so, yeah, quite frankly, that was just kind of I was happening to look at similar things at the right time. And I mean, yeah, weird to say, but the COVID pandemic kind of accelerated my career in some sense in that regard.
So, how were you able to get out of the epidemic stuff to move on to other things?
Well, I mean, I never completely gave up epidemics. So, again, since I do theory, my research all has a very common theme, which is how do small local actions manifest into global behaviors? So, whether I'm trying to control a large swarm of robots, the problem is similar to epidemics in the sense of I have to think about how to control one single robot to get the entire mass of robots to do something. The COVID problem was kind of similar, right? Like we had to create these social distancing rules. We had to control individual people's behavior to try to ensure that, mass immunity was reached, herd immunity was reached. So we analyzed very similar things as I do with swarms, just as with COVID, where the local actions were just very different, and the measurements from above were very different. But in the end, the math was very similar, right? So how does a robot move, and then what does the shape of the entire swarm then look like, versus how much travel is there between New York City and Philadelphia, and then how will that affect the total percentage of COVID cases in the United States? Right. So in the same way, these are both examples of complex systems where local actions, percolate and bubble up into globally measurable and design. Where you're trying to control things at the global layer, right, by affecting things at the local smaller layer. Right. Yeah, so as you can kind of see there, then even this launch of my Create Lab really ties together and generalizes all of this. So if I was to put a single umbrella around all my research, it's multi-scale and networked systems. So for anything of interest to me, you will see a lot of things connected to each other. So even these days, neural networks and spiking neural networks is of equal interest to me. And quite frankly, I've been very interested in neuroscience the last 2 years, just because in the end, I now even think of the brain as just a swarm of neurons, right? Individual neurons firing. Somehow I hate things and love things and feel things, right? Alan, please.
I'm wondering, I'm wondering if your research has been impacted by the funding cutbacks in university research.
Yeah, being that we're recorded, maybe I'll have to not say too much about this, but I can definitely say yes, my funding has been greatly affected. My military funding has gone up a lot, so I can buy a lot more hardware and things. But yeah, a lot of the kind of the basic curiosity-based research projects have been kind of paused, and it's hard to get those funded these days unless we can really transition into something real and applied within a 1 to 3 year timeline. These projects are hard to fund these days, which is unfortunate. All right, any other questions? Otherwise, I think all right, how much time do I have anyway? Are we going till noon?
Yes.
So okay, let's yeah, so maybe let's just I'll just talk about what good enough is, and just tie this back to the AI and exactly just how this comes into my research a bit, knowing I only have 20 minutes. So perception in humans is an interesting thing. So, we live in a world that was designed by us as humans, kind of an obvious statement, but in that sense, the world is designed for humans to navigate it, and humans see like humans do. And so, we know optical illusions exist, and there's a reason why we don't have optical illusions as signs in our everyday life, because they are hard for us to engage with. You can see here the picture on the left. You see these red strawberries, but if I were to remove that blue background, I don't know if I actually do it here. No. Yeah, you'll have to just take my word for it. Everyone knows what an optical illusion is. But you'll have to trust me that there's not a single red pixel in this picture on the left. So if I were to remove the black background and just zoom in on one of those strawberries, you just see gray. We see red just because our brain does a lot of interesting things that I won't even get into, right? This is the neuroscience aspect. But, we feel like we're seeing some raw image, but even this image that we're seeing has already been processed by our brain. So we are actually seeing it differently than, well, anyone else, than another animal in all of this. Similar optical illusion here on the right. These two dogs are the exact same color, right? If I were to remove that yellow to blue gradient in the background, you would see them as the exact same dog, whereas somehow it looks like they're literally opposite colors, right? So, is this good for perception? I mean, it's good enough for navigating in our human world. So this was something that came up in a Senate hearing maybe over 10 years ago, when there was a lot of pressure against Elon Musk and Tesla's self-driving. So how a robot or neural network sees a speed limit sign like this is, let's just say it's a black box. We don't really understand it. We do a little bit, but for argument's case now, let's just say we don't understand it. What we do know is that, oh, okay, sorry, I should have mentioned a little bit more here. What you see here, do you see these black stickers on this stop sign? Yes. There's these two black stickers and these two white stickers in this left picture. And then in these other two, you also see similar stickers. This is called a computer vision sticker attack. So does anyone know what's going on here? So these careful stickers
look like a QR code?
Yeah, well, no, so what they actually do is this is an attack on that stop sign for self-driving cars. 10 years ago, the Tesla's self-driving cars computer vision would have looked at this stop sign with those stickers on it and said with 99.9% confidence, that's a 45-mile-per-hour speed limit sign. It wouldn't even notice the stop sign. Just because of the way it processes information, which we may not fully understand. Somehow it believes that stop sign with the stickers on it is definitely, without a doubt, a 45-mile-per-hour speed limit sign. So you can imagine why that's a problem, right? If a self-driving car confuses a stop sign for a 45-mile-per-hour speed limit sign, you can only imagine the problems that might cause. But so now think about this, the flip side, right? So the poor robot computer, the problem with self-driving cars is that they, as robots, have to navigate in our human world, right? But what if our speed limit signs on the highway looked like this, like a QR code, right? So this would be a problem for us because we wouldn't be able to decipher these QR codes at all, right? But this would be a much easier world for the robots to navigate. So I say this because in some sense, we're asking the robots to do a lot. And when we talk about autonomous systems and sentience, we often don't think about what humans and robots do so differently and why, which is what I'll get into this in this next piece to hopefully try to make clear why this type of thing happens. Yes, Gabriel. You have a hand up?
The stop sign is a different shape from the speed limit sign, and even if the contents of the sign have been distorted, I would think that it would be doing something so fundamental as to see the shape of the sign and say that's the shape of a stop sign. And a comment on the QR code on the speed limit. There are already cases where people are putting bogus QR codes on top of legitimate QR codes, and so that would seem to maybe even simplify the vandalism attacks by just letting you put your own QR code on a speed limit sign, and humans couldn't tell it had been defaced.
Right. Yeah, no, that's exactly right. And to your first point, yeah, you would hope and think that there would be some fundamental safety checks like that, but that is the problem with AI, especially in safety critical systems. Like there are no safeguards like this. Again, we as humans look at that, and I mean the stop sign's red, right? So I mean it doesn't even consider these types of things. So it just the way it learns is it matches a lot of patterns. The thing is, this stop sign is not a normal stop sign because in all of its training data, it hasn't seen a stop sign with these types of stickers on it. And it just so happens that based on the exact combination of stop signs and speed limit signs it saw, this precise set of stickers happened to do this. So now, to be fair, like to engineer what sticker pattern would do this, that's a whole area of research itself, which is interesting in itself. But the point of this is to just show this kind of vulnerability, and most importantly, show really that no, they don't think like we do. So some things that are glaringly obvious to us as a human just doesn't even exist in the capacity of these agents somehow. Yeah, got a lot of hands up.
Actually, what it made me think of, um, Tesla changed the way the auto driving was trained from a traditional programming thing of coding. If a ball rolls into the street, assume a child is coming after it. Instead, exposing the app to a million videos of Tesla drivers doing good things, the right things.
Yes.
So, is that a significant improvement in the limitation of these systems that could help?
So yes, and therein also lies the danger, unfortunately, because again, this is the path that most researchers, technologists are going in, which is, oh, the solution is more data. It just needs more information. And in some sense, that answer is true. Like, so now, like the stop sign is a perfect example. All I have to do is show this robot one more picture, perhaps this one, and tell them, like, hey, robot, this is a stop sign, not a 45-mile-per-hour speed limit sign. And it would never make this mistake again with that one extra piece of information. But then that begs the question, right? If the solution is that we have to actually first show it everything it might see before we can expect it to operate well in that situation, which we do, first of all, we're acknowledging that these systems can never learn. There is no capacity to learn in a situation it doesn't fully understand. And the problem with that is sometimes it really believes it understands a scene or matches it to something it's seen before, when in fact it's just so different from anything it's seen that it does not realize that it's about to kill itself or something like that.
Yeah,
Alan?
that actually that's the perfect example of all of the taxis, that drive along the road fine, but then come to a policeman and don't know what to do.
That's right. Yeah, but so again, like the answer of showing it more and more and more videos is going to improve this. And at the same time, there will always be cases it hasn't seen yet that will always cause issues because, again, there is no capacity for the robot autonomous agent to truly figure out what it should do on its own in an unexpected situation. Another question, Alan?
As a meteorologist, I'm curious if these systems get degraded by weather. For example, if it's foggy, does it see the stop sign as well as when it's sunny? And also, when it's wet, the brakes know to pump the brake rather than worry about skidding. Or how does weather affect any of this stuff?
Yeah, I mean, weather affects most of this stuff terribly. So again, the big problem with a lot of these systems, especially these days, is I mean, yeah, let's not even go to safety. So Waymo and Cruise in San Francisco, I'm not even sure if they're operating now, but they were at war with the city. Because what would happen is when a self-driving car comes to an intersection where there's a slightly unexpected scene, like kind of you said, maybe there's a police car with a siren going off, or there's a fire truck and there's some smoke, so there's an emergency going on, right? Naturally, we don't have 10,000 hours of footage of emergency scenes in all San Francisco intersections. So when it gets to a scene like this, it knows it doesn't know what to do. So it knows it can't just treat it like usual, but then it has no capacity to figure out something on its own. So what does it do? I mean, it's a fight or flight reaction, fight, flight, or freeze. So in general, AI systems have to be pre-programmed to do something. If you don't know what to do, what do? Right? This is a pre-programmed fail-safe for pretty much any engineered system. For self-driving cars, that thing is usually freeze, just stop. But there are horror stories with this too. So there is a story of a self-driving car who ran over a person, right? And then was on the person and realized it's, in an situation it didn't understand, so it froze and would not get off of this person, right? So in that case, that was a huge problem. But even, not thinking about safety, just when the first car comes to this emergency scene and knows that it doesn't know what to do, it freezes. But then now when the next self-driving car comes, it does the same thing. So what actually happened in San Francisco was now you have a roadblock of 20 self-driving cars, all that have come into this emergency scene and don't have a clue what's going on. And they're now blocking the path from emergency responders. And these cars acknowledge they don't know what's going on, and so they just all brick up, and a human has to come and collect each one of them, right? So these are the types of problems that occur, and this is again where a human has a capacity that these robots just don't have, which is updating their own goal, right? When the self-driving car arrives at this emergency scene, its goal is still, I need to get to point B as fast as possible. So even if in a best case scenario, maybe it finds a road away from this emergency scene, it's going to just try to navigate itself right back into that emergency scene, more likely than not, right? Because it doesn't know that it's trying to even avoid this scene. It doesn't know it exists. It's just trying to get to point B as best it can. And then when it comes up against it, it has to figure something out. So, we as humans, when we come up to an emergency scene, when we don't know what's going on, right, we now kind of change our goal. Like, all right, I was trying to get to somewhere in San Francisco, the road is closed. Well, okay, now temporarily I need to abandon the goal of efficiently driving my car to point B. And I mean, just driving to somewhere I understand the scene a little more, perhaps, right? And so this is something that autonomous agents really aren't capable of yet today. So let's see, I think I'm just gonna jump now. This is just kind of a fun video. You know, when we go to like robotics conferences and we try to show a robot learning and show that it has successfully achieved to learn how to do a task, you will never see a video like this one on the right with this baby. So I don't know if the video is working. Hopefully it is. If not, I'll just move on. But this baby is trying to grab, you know, 1.5-year-old baby, 18-month-old baby is trying to grab this pink thing, but doesn't really understand the concept of a transparent object, right? So it kept trying to grab it through this plastic Tupperware container. And I mean, it's just doing trial and error, right? It has no concept really of the plastic thing blocking it. It has its goal of trying to grab that pink thing. And eventually, you know, it gets it. But so to me, this is a perfect example of a baby learning. But if someone was to design a robot that operated in this way, they would generally not call it a success. And I think this is some of the problems we're having in the community, which is, you know, what does learning truly mean? And my belief is, in some sense, we need a way for autonomous agents to define and redefine their own goals. So I could now go into this whole what does that really mean? And it starts with a conversation on what is the difference between these three different words: autonomic, automatic, and autonomous. In my field of robotics and artificial intelligence and control theory, I often find that these three words are interchangeably used, although they should have quite distinct meanings. And I think an autonomous agent has to use all three kind of words together in tandem in some way. So I won't get into this now since I don't have too much time. I'm just going to try to get to yeah, I guess I talked about this. Yeah, I guess I'll just kind of end with this. So my approach these days towards AI, and what I would call success for AI, is trying to make robot systems more like humans. And the main difference, I believe, between humans and AI today is that humans have two parts of our brain. We have a system one and a system two, a fast part and a slow part of our brain, right? We have our wiser self that was intentional and we're thinking about stuff. And then we have our more automatic type of responses, right? If I were to put my hand on a very hot stove, I don't have to think about it. My hand's going to immediately come off without thinking about it, right? But at the exact same time, if somebody offered me $50 million to put my hand on this hot stove and leave it there for 5 seconds, well, I can actually rewire my brain a bit. You know, I'd have to mentally prep a little bit, like, okay, like, let's do this. You know, how hot's the stove? But, you know, I believe if given a large enough incentive, I could force myself to put my hand on a very hot stove and leave it there. But again, knowing that I'd be fighting some sort of automatic impulses that are going to be there, right? So in some sense, I'm intelligent because I'm intentionally managing these autonomic acts. I believe this is something a car does not have the capacity to do today. So here's just a very simple example. You're driving down the road, you know, and you're kind of daydreaming, right? Like if your drive is uneventful, you might drive 2 hours, get there and think, wow, I don't remember anything about the last 2 hours. How did I drive here? And that happens because even as complicated of a task as driving is, we've done it so much and we're so good at it that it's uneventful and boring and easy. And unless we almost crash or something interesting happens, we don't really remember these very simple pattern matching we're just doing, right? You see a car, you kind of predict the behavior of the car. How? You don't know. It's intuition, right? But if you're driving and then all of a sudden a plastic bag a wave just flies right in front of your car, you flinch, right? So there's this moment where maybe your hands don't physically move at all, but somehow in your mind you were prepared to steer your car away from this if needed, right? And then there is a secondary check, right? So maybe the instant you see the bag, you flinch, and then you're prepared to do something, but then a quarter second later, your brain says, "Oh, okay, it's just a plastic bag. We can drive through it. You can call off this flinch." Right? But I mean, maybe if it was a couch that fell out of the car in front of me, right? That flinch now was actually a feature and a good thing because now I'm more prepared to follow through with that mental action that I was already starting. So this is something that's missing in autonomous cars and robots today that I believe is the key. And also, this is why cars phantom brake. You might have heard of Tesla's phantom braking type of problem or hallucination. And it's similar to this type of thing. If a car flies in front of a Tesla car, it has to go through the same process of something is there, and then there's still going to be an instant, some small amount of time needs to pass before it decides thing there, oh, thing is safe to drive through, right? So what is happening between that period of time is, I believe, the key that is missing in autonomous systems, right? There's a thing there, a quarter second later, oh, it's safe to drive through. In humans, I've already flinched and I've already prepared to flee away from this danger. The autonomous system freezes because it doesn't know what to do in this small period, right? So somehow humans are already acting. Humans are acting all the time, even without thinking. But autonomous agents have to actually go through their entire think, sense, plan, act loop so that if they don't have a clear plan, they can't act. And so that's kind of where my research has been going these days.
Can I ask, Cameron, do you think
Yes.
that we really are going to need to wait for quantum computing to make real progress in what you're talking about?
That's a loaded question. No, I don't think we need quantum computing to achieve these things. Quantum computing may help, it may not, quite frankly. I think quantum computing will give us even a lot more computing power. And in some sense, it will accelerate even further what we're seeing with Chat GPT and LLMs, meaning ChatGPT already has so much more computing power than us as humans that what it does looks intelligent, even though, as we're talking about here, it's kind of pattern matching. Quantum computing would unlock several more layers of that. But I believe just because it has more computing power, this fundamental problem I outlined here is still exists, which is it doesn't have a way to redefine its own goals or think about its own goals. There are other, even newer fields of research, more nascent fields of research that may address this. So maybe I'll just leave with one, a book recommendation, if I can type in the chat. Marvin Minsky. This is the godfather of AI. Society of Mind. This was a fantastic book in my mind. This was the book that kind of changed my life in the way I thought about AI as a swarm of agents rather than a centralized processing unit. So today, a computer literally stands for CPU or centralized processing unit. So we can't even think of what a robot could be without a centralized processing unit. But here's the thing. Humans don't have a centralized processing unit. The brain seems to process a lot of it, but in the end, my neurons are everywhere. And my emotions, my thoughts, my feelings are actually a full body type of interaction. So I believe I'm very interested in building computers without CPUs, if that makes sense, right? But synthetic autonomous agents that are more like how we are wired, right, using neurons. So there's a new field of even machine learning called neuromorphic learning and spiky neural networks. this is a very nascent field that's quite controversial. There are plenty of people who think it is not going to go anywhere. There are people who think this may be the solution that's going to change the world and achieve artificial general intelligence. And again, it's one of those things I can share. My opinion has ebbed and flowed. So, whatever I think now may change next week too. So, and I mean, yeah, maybe that's a good enough kind of stopping point.
Oh, did you want to show us tell some blimp stories from the recent event at Mason?
I don't, I mean, I could just post that was on the news, so I'm happy to just share a video or two about those. But no, I don't think I was planning to show those videos today.
When we had the presentation from the graduate student from Wisconsin, that was the first exposure that any of us ever had to blimps being any part of this.
I see. Okay, well then here, maybe I can just show. Does this work? All right, here's a 2-minute video on a competition I've been hosting with the Navy and participating in.
Quidditch from the Harry Potter series, but now a George Mason University competition is doing something similar, but with balloons.
Okay, our Fox 5 photographer Ed Koch are sharing why teams are facing off today in a blimp battle.
This is a national robotics competition, kind of like soccer in the air. So 2 teams, 30-minute halves. It's kind of like soccer. You catch the balls, you move them through the goals, and the most points after 60 minutes wins the game. But the interesting thing about this game is that the robots play the game entirely by themselves. This project started 3 years ago just by myself with a small team in the electrical engineering department. And we very quickly realized we need some mechanical engineering help, because until we had mechanical engineers, all we did was basically take a party balloon and attach some motors to it and try to fly it around. Right, so electrical engineers, they will program a brick to fly. They don't think about the aerodynamics. You got this, you got this. Press B. Some robots move with propellers, some have kind of wings, some have other types of control surfaces or a rudder. After we integrated mechanical engineering, we were able to remote control these robots very, very well. But then now, as the game moves towards full autonomy, then we needed to start bringing in computer scientists to help us with the artificial intelligence.
Some undergraduate students, they don't have the training like other graduate students do, but they do come with crazy ideas, and I always let them try.
Trying to see them score a goal, it's kind of like watching your 5-year-old kid try to score and being so proud when they actually do it, even though it shouldn't be that hard.
We want to promote this whole competition as actually a motivation for the student to get more involved with robotic technology, AI. So yeah, we are going to make this actually more and more exciting and also interesting.
1, 2, 3.
Man, if you just had a fraction of that type of intelligence, unbelievable.
All right, so yeah, I mean, so that's just a fun game. That's a great recruiting tool. 2 30-minute halves.
Can I ask Cameron, is this the first exposure that the students have to working in groups with people from different fields to put a device like this together?
The blimp, yeah, we have created a kit and curriculum, like a 10-week curriculum for 9th through 12th graders, so high school students who have never touched a robot. We have an instruction manual and video, and you should be able to build one of these and get it remote controlled flying within 3 to 4 hours by yourself. So yeah, we do have that.
I'm talking about training the students to work in teams with people who bring different fields to the table, which is something that seems to be in too short supply in the way we normally train students.
Yeah. I'm heavily involved in robotics competitions, so I only showed one here, but I'm participating in a lot more of these because I believe these are awesome projects where we bring together a lot of different people with different expertise, and not even different fields like mechanical engineering and computer science and systems engineering or what have you, but I'm talking even like professor, postdoc, PhD, high school student, middle school students, all working on the same team. And I mean, you saw some of these robots. Quite frankly, some of the best innovations are, an eighth grader decided to cut our spoon and use it as like a blocker for one of our robots so it wouldn't get caught in a net or something, right? So these randomly creative innovations actually help support our team. uh, so I mean, yeah, it's the first for a lot of people, but some people do come with experience, especially these days. Kids in grades like K through 8 have a lot of access to programs like First Robotics that have national chapters.
Thanks so much for showing us that. Yeah, I was actually really captive when you in the video were saying, well, starting with these people, and then we needed to add these people, and then we needed to add those people, and look what they could do.
Yeah. So we literally started with only electrical engineers. We programmed the balloons and then eventually added mechanical engineers and focused on the different shapes. And then, yeah, brought in computer scientists. And now the game needs to play itself. So it has turned into, I mean, yeah, designing artificial autonomous agents.
This is wonderful. Cameron, thank you so much. Uh, Folks, any other questions for Cameron before we let him go plunge back into his stuff? And as I mentioned, Cameron, if you could just send me your snail mail address, we will send you a handsome pie mug in appreciation for your presentation today. And again, thanks so much for plugging in at the last minute and cobbling together this amazing stuff that is your field. Just amazing.
Thank you. No, it was fun. And I think, yeah, presentation would be being too generous. But thank you.
Folks, anything else for Cameron? Oh, just kind of stray things, if you could. I know it falls into the basket of just getting more data when we have to really think differently about it. Do you have any opinion about the Tesla thing of LiDAR or not? They removed LiDAR from the cars because it was too expensive, and now say cameras are enough. And then it just looked to me like the handful of the biggest crashes were things that LiDAR would have prevented. What?
Yeah, that's what I'm happy to just even publicly say. Yeah, using only a camera with no LiDAR is extremely dangerous and risky for a lot of the reasons I talked about today, right? Think back to the stop sign example. It's like saying, well, I can figure out the stop sign from looking at what it says and the shape. I can ignore its color. And someone like me saying, well, the color is a very good validator, right? Why would you remove that in a safety critical system? You're right, you might not need it most of the time, but there may be times where everything else made you think that stop sign was actually a 45-mile-per-hour speed limit sign. And if you just had a color sensor that told you it was red, you would have never made that mistake. That is what Tesla's doing right now. And yeah, I mean, I guess even as Missy Cummings would put it, I think, having any safety critical system rely on only a single sensor stream, I believe she has said has never been done and should never be done is definitely my opinion as well.
Mhm.
It's too risky.
All righty. Well, thank you again so much, Cameron. And I know that I, for one, will be following your research to see where it goes.
Great. Well, thank you. It was great meeting you all and talking with you all. Hope you have a great rest of your Saturday. Bye.